Alright, welcome back trappers. In this tutorial I'm going to continue off of the last tutorial where we downloaded the Drosera CLI, downloaded our first trap template, and ran the dry run command. But what we didn't do is we never actually deployed a trap on chain. So that's what we're going to do today. So first, let's just take a look at the commands that are going to help us do this. Drosera help. So primarily these are going to be the plan command and the apply command. Plan is simply going to analyze our Drosera toml file with our traps, the list of our traps in it, and come up with a plan, but it's not actually going to do anything. It will not execute this plan. When we run apply, under the hood it will run plan again, get a fresh plan, and then we'll be prompted to execute that plan, which will either be creating a new trap that doesn't exist or an already existing trap with some update to the trap code or some parameters about it, and it will be updating those. So additionally, let's just check out the config command on the side here, just to look at that. And this is essentially parsing and printing out our Drosera toml file. And one thing I want to point out here is that our private key is missing. The trap template that we downloaded does not come with a private key, of course. That is something that you need to provide yourself. So let's go add that. What I'm going to do here is just open this in VS Code. Okay, so no private key field here. And also, as a caveat for this tutorial and some other future tutorials, I'm going to use a local Ethereum network, just running locally on my laptop, and a local Drosera. Just things will be easier. So I am going to grab this from over here, and I think we'll just comment this out for now. And this is what I'm going to use now. So it's my local Ethereum, my local Drosera seed node, and my throwaway private key here on my local valueless network. And then here's my trap. Okay, so let's try out Drosera plan, and we have with our one trap, my trap. Okay, so the plan generated says it's going to create a trap for my trap. You can see my trap right here in our traps, and we can see my trap right here. So these names are corresponding. And then it just gives us some of the same points that we had from that we specified for the trap in the Drosera toml. Importantly, what the response function will be. If the response is triggered, then it will go to this contract and it will execute the function with this signature. Additionally, we have things like cooldown period blocks. If the trap executes, then it can't be executed again for at least the next 33 blocks. Minimum number of operators. This is the minimum number of operators for the trap to actually come to consensus and execute a response. So the higher number you put on this, you're getting a higher degree of decentralization, so to speak. You can set a maximum number of operators and a block sample size, which is how many times the operator needs to call the trap's collect function over how many blocks, 1 per block. And so 10, so call collect on each block for 10 blocks, and then pass in the array of all of those into the trap's should respond function, where then, when it has multiple blocks worth of data, it can essentially do what you could call some time series analysis. So you can shrink this, make it 1, make it many. That's up to you and your use case. And again, we're here at 1, but we could have multiple traps in here. Some can be create, some can be update. At the end, we just get a summary. What the total required cost will be in Dro. Creates will cost something. This is technically for my local testnet. I think it will be different on testnet or mainnet. How much Dro you have in your wallet with the private key you supplied, and a total estimated gas cost. So that all looks great. I want to deploy this on chain. So let's call Drosera apply. Okay, now this might look a little familiar to you. This looks like the dry run command, because under the hood, the apply command first runs dry run to check and make sure everything is good. Then it generates us a plan down here, just like we saw. And now, if everything looks good, then of course I'm ready to apply these changes. So let's run that, and all right. This will be slower on chain, but on my local net here, the block times are very fast. So that is finished already, and it says it created my trap and how much gas it actually ended up using, etc., etc. Okay, now if I come take a look at my Drosera TOML, we can see I have a new field that was added to specifically my trap. And that is the address field. This is the address of the trap config on chain. Now let's verify that it's actually there. So this is the Drosera Explorer, and you will be on app.drosera.io here on Haleski. I'm just running the same thing locally, so there is no traps. Mario is sad, but we just deployed a new trap, so let's just refresh. And voila, there is our trap. Okay, right, we can see our operator 1 min, 2 max, response function, block sample size, all of these fields that we set, and here they are. So congratulations, you just deployed your first trap on chain, and it's just as easy as that.